Hello, everybody. A warm welcome from Berlin. This is another part of the AIOps Explained series. Today, we're going to talk about infrastructure automation, and that is now a new part in the IBM Cloud Pak for Watson AIOps. And to give you an introduction and overview into the topic, we have a team assembled in here, which is led by Seville Mostafa. And today we also have Ian Watts here, Jason Frey, and Khalid Ahmed. Seville, would you kindly introduce yourself, please?
Sure, thank you. I'm Seville. I am the technical product manager for infrastructure automation, the newest member of the team, actually, and I'm located in New York, and I'm really looking forward to sharing what we have with everybody today.
Thank you. Ian?
Yes, hi, I'm Ian Watts. I'm the program director for the Cloud Pak for Watson AIOps and a couple of other things as well. So leading up the development team, Jason and Khalid.
Very good. Jason?
Hi, my name is Jason Fry. I'm the chief architect of the infrastructure management component of infrastructure automation. I'm located in New Jersey, and I've been working on infrastructure management for the past 15 years as a developer and now as the chief architect.
Thank you. Khalid?
Hi there, I'm Khalid Ahmed. I'm the distinguished engineer working on the Cloud Pak for Watson AIOps, as well as infrastructure automation module. I'm based in Canada, Toronto.
Nice. Today we're going to have a few slides. We're going to see a demo system. We're going to give you a hint into where the documentation is stored. Just to kick it off, let's go into the agenda. Seville, I think you're going to start.
Yes. So we're going to spend a few minutes on what is infrastructure automation, and then we're going to demo the distinct features within it and also discuss some of the out-of-the-box integration use cases that are available for our clients. And then finally, we're going to leave the presentation here with a link to the documentation for further reading. So if we can start with what is infrastructure automation. Infrastructure automation is a module within the Cloud Pak for Watson AIOps. Any client with Watson AIOps license is entitled to install and use infrastructure automation. Installation is operator driven. It could be installed as a standalone or together with the Cloud Pak. It brings together two distinct features, the service automation and infrastructure management. Both provide a toolkit that allows the IT operations teams to provision infrastructure, build their IT services, and deploy them, what we usually refer to as day one operations. Once deployed, they would also be able to automate the deployment, manage the infrastructure, and report compliance, which is what we refer to for the most part for day two. So let's do a scenario quickly with how this works for the IT operations teams. The IT admin team would start for day one operations to build their services with the service automation capability that allows them to use Terraform and Ansible technology. They create or import existing templates. They can assign parameters and tags and variables. They can create connections to clouds, infrastructures, containers, and they also can assign users and groups to who can see from the IT ops team who is allowed to do what with what they're provisioning. And this is all done within the Terraform and service automation by namespace, right? Everything that they create, the IT admin creates, would be promoted to a catalog where the remaining IT ops team would then come in, choose the templates or the connections that they need, and they don't need to enter anything else at all, no variables, nothing, no profile, everything is there for them. All they need to do is enter their SSH key and deploy. So this becomes low code, and this also frees up the IT admin. Developers can come in and thread these templates together to create the complex services that they need. All the services, again, that are promoted to the catalog can be seen and leveraged based on permissions, right? So the IT admin can give as much permissions or be strict with it. Once the service is deployed, now it's time for us to leverage the infrastructure management component of infrastructure automation. And it brings a very robust capability for the IT operations team to discover the inventory, everything that's in their environment under one pane of glass, right? It could be, this includes the containers, the networks, the storage management system. It actually maps the relationship and listens for changes in order for the team to be able to build a really rich model for day two operations management. They can scan some of the contents that are within and also combine that with the auto discovery, which I just mentioned, to create actually advanced security and compliance policies. There's a robust reporting capability with a chargeback capability that monitors what's happening within the applications and within the resources that are deployed. And finally, they have a toolkit that is designed for systems and operations management that helps them integrate with the CMDB and web services and so on. So this is sort of the overview of what infrastructure management is. And now we're going to go into actually demoing day one, which is the provisioning, and also day two. So I would like to pass it on to Ian to demo the day one operations side. Over to you, Ian.
Thanks, Seville. Okay, let me just switch over the sharing. Hopefully you can all see my screen. First off, this is, I'm going to kind of give you a quick demonstration of the infrastructure management, infrastructure automation component that we internally call Cloud Automation Manager. It basically is a Terraform and service library abilities. And so I'm going to start with just talking a little bit about the service library first. So I'm going to go into our Cloud Pak for Automation menu here, and I'm going to choose the service catalog. On the service catalog page, I'm going to see a number of options that I can have here. You'll even notice that this one that I'm going to choose, the virtual machine on Microsoft Azure, has two different versions of it available. So I'm going to click on that one. I'm going to try to deploy that. This is kind of set up as a end user portal. You can basically create a group and have as many people as you want added to it that have access to this service library. They have the ability to deploy systems using these services, and they don't have to be very technical at all. As you're going to see, I'm going to deploy a service into Azure, and one of the things I'm going to do here is I'm going to choose the new template that I just updated yesterday, and I'll show you in a second how you can create all these. So this slightly newer template, I have the ability to have plans. Today, this one only has one, but I'll show you how those are configured. And so this is going to deploy a standard plan. So I'm going to click Next. When I get into the plan, it gives me a bunch of variables that I need to fill in. Underneath the covers, this is doing many different things. So it could be doing Terraform, Ansible, REST calls out to systems, conditional flows, emails, etc. And so these variables are flowing into that service, and you can have as many hard-coded as you like, or you can have it as flexible as you like. But these variables are there for the user to then customize it the way they want to. And so right off the top, we choose a namespace. This is more about isolation. It's kind of an advanced topic. I'm going to skip over that for a moment. The service instance name, you can just call it whatever you like. Call it test Ian. That's my name. And then, oh, looks like I've already deployed 4 before. Okay, so I'll try 5 this time. There's a environment here. This is a tag that gets added to the systems. So if you've used any of the cloud providers before, or even even VMware and other things, they allow you to create tags on systems to allow you to help group and organize the products. This service has a number defined, and I'll show you what those look like in a few seconds. But this one, instead of allowing the user to enter in the value and have it typed and then have potential for people spelling it differently or different use, like upper or lowercase kind of situations, we can create a dropdown so that it's very specific and they have to choose one of something in that list. This allows you to make sure your grouping is solid and you don't have any breaks in that. This particular service allows me to decide what the user ID is going to be. I'm going to enter in a password, make sure I spell it right on both of these pages here. Good. Okay. And then a public access key. I'm going to enter in my public access key here. You probably won't be able to see that. And I'm going to put in my email address, which you probably won't be able to see as well either. But the point is I'm entering in user information that I want to have configured on this VM in the public domain space. And then I'm going to click deploy. So now I have two options here. I can go to the instance, or I can kind of view the library and maybe choose something else. So I'm going to go to the instance. When I look at all the instances, I can see all the previously deployed systems. You can see I've been actively kind of playing around with the system for the last few days. There's a system here that is in progress. So I'll show you what a deployment looks like in progress and some of the features of that instance view. So at the moment, it is currently in progress. There is not a lot of visibility here of stuff, but this will fill in as the system deploys. So if I look at the log files, I can actually see logs as they're running on the system. And there's an activity log, which is, if you're familiar with the Terraform logs, this is where the Terraform logs will show up if you're running Terraform, or if you're running Ansible, it would have the Ansible logs here as well. If you're running multiple templates or other things within the system, they'll be listed here individually, and you can click on each one to see what's actually happening in each of those different templates. So again, as this is running, these details will fill in. I'm going to take this break then to go show you what a service looks like when I go to create it. So to look at those services, I'm going to click on the menu and I'm going to click on library. So this is the library of services. This is a different persona now. Now I'm logged in. I wouldn't say I'm logged in differently. In this case, I have access to everything, but a persona that is a creator of services would have this library view. And then, for example, here, this is the service that we deployed earlier. You can see that there's a draft version of that service that's out there. It hasn't been published, so it's not available for public consumption. There is this published version that was version 1, and then the version 2 one that I just deployed. And I made that change yesterday just to make, there's an email component there that I wanted to highlight and show off. But in order for us to edit the system, I have to actually create a new version to edit it. So since I want to show you how cool it is to drag and drop things around and make a service, I'm going to do that now. So I'm going to create a new version. And I'm going to call this one 1.0.1.3. And I'm going to say it's based on, so this is where I'm choosing which one to copy to start with. And then there's an advanced section here. I can actually say that my system can upgrade from specific versions to this new one. And if I wanted to allow it to downgrade, I can allow that as well. What this will do is the end user will have the ability, if they deployed a version, for example, of the service called 1.0.1.1, and they want to move to my new version that I'm about to create now, when it's published, they'll have the option to upgrade, and it'll basically just ask them for the service parameters again. They can reuse any of the parameters that they already created, and in this way, because of using Terraform and Ansible, they're kind of, the way that they run is you can execute them over and over again, and it just continues to try to make the system as designed, meaning as it was coded. It's not a list of API calls kicking them off. It's Terraform and Ansible, which are very much infrastructure as code, and so you kind of list this desired state, and it tries to make the system that state. On this new version now, you can kind of see there's the new version number. And here's the overview page. So some highlights on the overview page. Obviously, you can have kind of some description and give the user some details about what the system actually does so that when they go to choose it, they have an idea of what it is they're choosing. I mentioned tags earlier, and so we talked about environment. And so this is an example of a tag that can get created for environments. And this is what that view looks like, how I actually map it to the actual value, what it looks like on the front end. We've also got a number of ones that we by default add to the systems. You can modify these if you like, or add your own. So you can add tags down here. So let's talk about the actual fun of this though, which is composition. So in the composition flow, you'll kind of see a couple of things. So first off, there's this primary flow, then there's an error flow, and then there's a custom action flow. So quickly, what this does is I'm allowed to drag and drop any of the templates or decisions or emails. And you can see it's got right now, it's got a Terraform template and an email. But I could do REST hooks into like IPAM systems for IP management to grab an IP to pass into the templates, or many other different things to use. And then, of course, we have a whole bunch of samples to connect to different cloud providers. The list is very large. If I state it all out, I'm sure I'm going to miss one, but our documentation has a good list that you can review. And then on the Ansible side, there's also a huge number of templates that are here that I can use to kind of make things. So what we kind of did with this system is we looked at what were the best in breed deployment technologies at the time. And so Terraform, we think, is a very broad set, very openly supported, and lots of backing for deployment technology of infrastructure. And then Ansible, we think, is the kind of industry leader in software configuration. It's kind of taken over from where Chef and Puppet used to be. And I think Ansible is now the kind of the reigning champ in that space. So by having these two integrations here, you're kind of getting best in breed of infrastructure management, deployment, and software configuration and management from that space. And it's as easy as basically just dragging and dropping a template into the flow. It immediately shows up, and then I can go and quickly configure it. You can leave a lot of things blank, frankly, but you can then code certain things. We've made it easy to link parameters. So say, for example, an output parameter of the virtual machine we want to use as an input parameter. Let's say the credential name, for in this case. And since in this view here where I'm choosing link parameters, there's parameters that were inputted by the client that I can then choose to use. And in this case, maybe that's this one here. When I go to inventory name, we didn't know the IP address, right? So we didn't set a host name or anything. And so what we want to do is look at the template that ran first, which was this case, the VM template creation. And the output parameters of that template are here listed. So I can actually choose the public IP address, for example. And so now I've got the public IP address and the credential. And in fact, I'll probably need to change this template a little bit to pass in the user ID. But you kind of get the idea that now I have this ability to kind of link parameters between the different services. And there is a kind of a schema way of acknowledging these parameter links and stuff. So talking a little bit more about these flows. So there's an error flow. So at any step along the way, if any of these fail, it will trigger the error flow. This could be as simple as creating an email, or you could use a REST hook or an integration out to some sort of Servicenow library. So under integrations, I can upgrade a Servicenow ticket, for example, and trigger that. And so it becomes very easy then to have, these flows happen. And so it could be that, maybe this email goes to the person that created it, or maybe it goes to a system admin who then has to go and look at what's going on and try to figure it out. This icons at the top are telling me whether I have variables that need to be configured before the service is complete. Quickly talking about custom actions. So custom actions allow you to create, let's say something like I want to have the ability for the user to restart the VM. Other good examples might be to run a OS update, or potentially to change my JVM settings, or any other thing that I would like to do. Create that. So now you'll see that I'm in this restart VM action, and I have a primary flow and an error flow again. And at this point, I can do whatever I like inside of those flows. One thing to note when you're doing these custom actions, obviously, this is likely to be more of an Ansible or REST hook type action, although there are some templates that you can run that are terraformed against this system. But you will likely be taking output variables of your service and using them in this primary flow as input variables. And so that's an important thing to remember. So let's talk a little bit about the parameters. So when I click on the parameters tab, you'll notice it looks empty. I'm viewing the parameters that are available or used or created, I should say, in that action that I just created. So one of the things to watch, sometimes you may not notice that there's differences there. So I go back to the provisioning action where I've got templates. And so you can see now all the variables that I define or I can define here. And you'll notice like things like email ID, it was just created, so I can create any parameter I like. So what's your favorite color? Oh, it's a key, so I can't use spaces. Sorry. I was thinking of the description name. Okay. I'm going to make it read write. So I have the ability to create invisible parameters. This is where I want to maybe hard code, say something like the image name or some setting that I don't want the users to be able to see. Read only means I'm going to create a variable that will be visible to the end user, but they can't change it. And then read write means that now they can have the option of changing it. So I can actually have this as a string. I can say whether it's required or not, and I can specify specific options. I would recommend using this, especially if you're using Terraform. Case and other things are important, and it's very unlikely that your user knows the Terraform values that you're trying to pass in. So you can go ahead and create specific options. There we go. So one of the things that I like just to highlight here is you got kind of default value, and then the fact that there's like a display name as well as a value. So this is important because if I'm actually doing something like the image size, specifically like Amazon or any of those, it could be something like T2 small, T2 tiny, T2 large. That doesn't mean a lot to end users, right? So I might say something like, for example, let's say 4 CPU, 8 gig RAM, and then underneath I might say T2 medium. So now I can translate for the user what's actually going to be going on. 2 CPU, 4 gig RAM, for example. So in this way, the user doesn't need to necessarily know the Terraform context, or even in this case, this is like an Amazon or a Azure special name of a template, right? But it translates it so that they actually, can understand and know what exactly they're choosing. So anyway, that's why these variables are really cool. You can also have, I'll edit this one here so you can see there's the ability to kind of create, there's a validation rule. I think it's on password. Sorry, let me check. Value required. Oh, well, there's a type called password. And you'll notice when I typed it in, I had to type it twice, and it's, it has the eye icon, so I can kind of, like, it's by default hidden and all that kind of stuff. There is the ability to kind of use a regex to validate the field before it comes in. So there's that ability as well. There's the next area here is activity parameters. So basically what this is, in this interface, it allows us to kind of view the different values being used in the templates, and just so you can kind of easily try to use it later, perhaps. So you can kind of see this one here is coming from this guy here. Its output parameter. So that the output parameters are an important piece. When I go back to the service that we deployed, it's going to have these two values listed for the user to consume. So they're going to know it's public IP and private IP, and we won't kind of expose the user and password. They entered it themselves. And that way, there's the ability to kind of decide what you show. You could expose any parameters you like. Let's talk a little bit about plans. Plans in general, you can create as many as you like. You want to keep them fairly simple. I've seen this used in a couple of different ways. Some people will create different plans for the size, so it's not a drop-down at some point. Maybe it's a small, medium, large deployment because it might dictate how many VMs are deployed. Sometimes people create services that are, hey, my test environment, and the plans would be run it on Amazon, run it on Azure, run it on VMware. And in that way, it kind of allows the team to kind of have one service that they can call and just kind of redirect based on the plan. And they don't have to worry about what kind of templates or anything are happening underneath. To them, it's the same set of questions, and they get something just in a different place, and hides a lot of that for them. So some people use it for sizes, some people use it for location, and I've seen it used for dev, test, prod as well. And so that may have different implications. So the environment may be monitored in prod and maybe pre-prod, but maybe in the dev test environment, it's not set up with monitoring and configurations. And so, one of the powerful points of all of this is, yeah, you can deploy a VM using any number of technologies, but with a service, you can integrate it into your backend IT processes. And this is probably one of the more powerful components of the service library, making sure that it's connected to your IT service infrastructure. IPs are reserved in the right systems. You've got monitoring configured and set up the right way. depending on where you're deploying it. Maybe you're updating CCMDB records, you're creating ServiceNow tickets on failures, or probably even CCMDB updates just to keep track of systems. So in that way, that's what the service composition is all about. The code itself for all of this is kind of a JSON format. There is the ability to import it. You can also save, and you can publish to Git. You can do test deployments and a whole bunch of other fun stuff in here. So let's take a quick look at what it looks like when we set this up. And the only reason I'm going to do that, and it's just warning me because I didn't save version 3 yet, but I don't need to save it. So just to quickly look at cloud connections. So we're connected to a couple of things, Turbonomic, we're connected to Microsoft Azure and Amazon EC2. And the only reason I'll click this is just to show you the list of cloud providers that come out of the box. So you'll see most of the standard clouds that you're used to connecting to, and probably a bunch that you've never heard of. There is the ability to inject a cloud provider, so we call that custom cloud provider. So if you search Terraform providers, you'll find a large number that have been created. And so there's potentially cloud providers for anything that you might need to connect or manage. And you can easily import those into the system and add a connection provider here. And then you can use them just like anything else in the system and drag and drop them in your Service Composer. So that's enough about cloud connections. Interestingly, there's two other parts here that I would like to point out. So we connect to what we call Ansible Tower. You can use the open source AWX. Obviously, if you want support, you probably want Tower. And so that's how we pull in the Tower templates. We're not running Ansible directly in the system. In the future, we may start to use what IM has. And so Jason will talk quickly about, in the next part of the demo, a little bit about the Ansible implementation they have in that side. But this is, right now, we're connected out to one. And the other part is Terraform Versions. So if you've been using Terraform for a little while, you may know that Terraform's been going through a lot of changes recently. There's a large number of versions out there today. As versions become available, they will be added here as long as you're updating your system. You can actually create your own if you want to, and import a specific version. And you can kind of set the default for each. In the service view, I didn't show it, but each template that you drag and drop in, you can specify what version to run, or you can leave it as default and it will run against the default. This is pretty important because a lot of templates, especially between version 12 and 14, for example, and definitely to 1.3, we've seen the template schemas for some of the providers change as they're taking advantage of some new Terraform abilities. And so this allows you some control. Your templates in the past don't break, but you can actually write new templates using the new providers if you want to. And then at some point you migrate your templates. And that might be why you would need a service version change. So as your templates update, you can update the templates in your service, and then you can do a service upgrade. And because it's Terraform, it would just do a plan apply against the new template. It would tell you in the plan whether it needed to destroy things or whether it would actually just apply them. In most cases, it will apply unless you're changing something pretty basic, like like a basic image name or something like that, or network. That may cause it to redo. Yeah, go ahead.
Maybe a silly question, but where do we get all these versions from? So you showed us how to create custom versions, and you also said we're getting new versions in here, but how do we get the new Terraform versions, for example, in, or if AWS decides to put a new pattern in there, how do we get these changes into the system?
Yeah, great. So there's two parts to that question. So first is the Terraform Engines. That's what I'm actually showing here. As Terraform releases new GA versions, we are pulling them in automatically into our product. So each of these rows here is a different engine we have, which is running we've podified it. So it's running in a pod. When you execute a template, executes your template on the pod and then destroys it. We do that on purpose to ensure that we don't have any ability for somebody to write a nasty template that could then go and reach out and try to discover settings in the rest of your system. We know that if you just run Terraform Enterprise, there is the ability to kind of side hack or be a bad actor, I should say, in your system and run templates that could potentially go and sniff out details of other templates. Because generally when they run, some of the variables end up as environment values, especially passwords and stuff. And so in this way, by having each isolation or each execution as its own pod, we isolate that environment for that run, and we reduce any risk of a nasty or a bad actor running in the system. So that's on the Terraform version side. Let me talk about on the library side. There's two parts to that question around versions. So the templates themselves, you've seen this service version. So all these services that I'm dragging and dropping, right? But where are all those templates coming from? And that's where there's this templates view in the library. And by default, we ship 68 of them. If you go online, there's probably hundreds of thousands of templates available to you. A very large set. Of course, you would have to vet that they're any good or useful to you. But when you did, what you should do is go and clone that into a Git or GitLab directory or source repository for yourself. And then you can import a template. And then from there, you can decide you want to make that template a part of, everybody gets to see it, or sorry, is it a part of a namespace? So there's an isolation level. I won't get into because I think that spends a lot of time here, but everything in the system can be isolated to specific namespaces, and we can create, a namespace per user or per group, or you can have it fairly open like I have it today. And you can also kind of create it globally accessible, so make it available for everybody. And so that depends on, whether you want to make this template a part of something that you're just playing with, or do you want the entire quote unquote organization or whatever you're scoping your system to have access to that system. And then you can kind of import it from any of these locations. So you can import it from any of these locations. So you can see we have a different types here. I would suggest using GitLab or a GitHub. There is Bitbucket, and there's even importing from a zip file. I would suggest that, given the nature of Terraform, it's probably a good idea to use a GitHub or GitLab environment or a Bitbucket. And then you just specify, some directories, where it is and some access credentials and tokens. And that allows you to bring in a system. So let me just give you an example of one. So this is the overview tab. It's kind of some overview features and details about it. This is stuff we wrap around the template. So as you import it, you can add a bunch of details to the system. It gives you some of this extra information. Here's some details about where the template source is and the parameters that so I talked about parameters at the service level, but you can actually do a lot of work at the Terraform template level as well. And so you can actually variabilize the templates and make them easier to deploy. You can actually deploy a template as well. So you can see this template deploy button down here, but it's not going to hide any of the Terraform nastiness for you unless they've gone and done a bunch of stuff in here. You can see some regex examples here where they tried to make sure that your public key was correct. Password set is based on certain standards that maybe that provider is requiring, and other things like that. And you'll even see here, so they'll set some options for your region so that you don't have to go and try to figure it out. The reality is, this is probably, if you go to deploy it, it's probably too many parameters. So by creating a service, you're going to allow the user to, so if you deploy a template directly, now you have to know what connection to use, what Terraform version it should use. There's a bastion, in some cases there's bastion required. Again, here's that drop down that I can get, but then there's going to be some other stuff like virtual machine size. If you're going to change it, you better know how to specify these values, right? And so things can get a little tricky if you deploy just straight a template. And that's why I think it's very powerful for the person who writes the template to then write a service to make it so that an end user can really use it without maybe knowing the dirty details of, how to deploy in Amazon or Azure. VMware, in fact, I think, all of those have a lot of, things like shared directories and template names and things like that, an end user won't know.
Cool, I like it.
Yeah, so let's now quickly just show what a service looks like when it is deployed. And then I think we'll probably just wrap up from there. So I'm going to click on the Instances tab. You can see it's active now. Like I mentioned before, the output parameters, so I can see that my public IP address is this guy here. Obviously, we're probably going to highlight or hide that, or it'll probably be gone by the time you see this video. You can see also the service parameters, details that I entered. Password is going to be completely hidden though, and your key and stuff. So you're going to have to at least remember what you specified. Your tags on the environment, so you'll see what tags were set or should be set, and then your log file will show. You can get into the template details if you want to understand a bit more about the template itself and what it deployed. So you can actually click on. So for each step in your service, it'll have an entry in that table there. And then you can actually get into it and see all the values that it passed back and forth and the output variables of that and input variables as well. So that's kind of a deep view of the service catalog. Are there any questions before I hand it over?
Not from my side.
There are two topics, I guess, that are of interest, and I think in the integrations section we'll talk about it. So there's an integration with Turbonomic where we can do optimization. So that's basically kind of triggering a edit of a service once it's deployed. So I'll just quickly talk about that. So when I'm on this service, I can click edit, or I can run the custom actions if there are any. I can upgrade the system if there's an upgrade, and then of course I can terminate it, which means basically destroy all the resources, or I can delete it, which actually deletes the service. It may, if you haven't terminated though, it may delete just the service and leave behind the actual systems. When you click edit though, this is the ability for you to basically rerun those templates against your system. And so if you make a change, say I change my password, it may go and update my password on the system. That's an example. In this one, I mean, you could be changing anything that's a variable that is exposed. And I think that's probably all I want to cover today. So if there's no other questions, I suppose I'll hand it over to Jason.
All right, thank you. Share my screen. All right. So today I'm going to demo the infrastructure management component of infrastructure automation. Infrastructure management is a day one and day two management system for multiple clouds, virtual infrastructure systems, container systems, etc. So let me jump right into it. We're going to go over and click on infrastructure management. And this is infrastructure management. Infrastructure management is IBM's productized version of an open source project known as ManageIQ. ManageIQ was acquired by Red Hat back in 2012 and released as Red Hat CloudForms. Red Hat CloudForms transferred from Red Hat to IBM and is now known as the infrastructure management component of infrastructure automation. When you first log in, presented with this dashboard. This dashboard gives you an overview of your system with a number of configurable widgets and dashboards that you can see various information on about your systems. But before I get into the dashboard directly, I want to jump into where we get the data from. If I go over to Compute, Clouds, Providers, you can see I have a number of providers already at it. Providers is the term we use for external management systems. These can be public cloud or private cloud systems, infrastructure management, virtual infrastructure systems. So here's an example. If I wanted to add a new cloud provider of a number of the systems that we support on the cloud side, including Amazon EC2, Google Compute. We also have support for IBM Cloud, IBM Power Systems. So we support Power Systems. You can see IBM Cloud Infrastructure there, which is a management system for IBM Z systems. We can add a number of cloud providers, infrastructure providers. So I'll go over to infrastructure providers. You can see here we have VMware vCenter, OpenStack, IBM Power HMC. I won't go into every single type of provider page, but we support container systems such as Kubernetes and OpenShift, IBM Cloud Kubernetes, physical systems via the Redfish API, network systems, storage systems, automation systems such as Ansible Tower. But I'll jump back to clouds now, and I'll show you one of the systems that we have. So I'm going to click our Azure system. In the Azure system, you can see that we get some information about the Azure system that we've added. This particular system has 7 instances running on 6 cloud networks. There are 669 flavors available for provisioning. And as you dig in, you get a lot of rich data about the system that you're looking at. We have relationships to other parts of the system that you can click through, and all this is navigable so you can see what you actually have. So if I look into the systems that are on my Azure system, you get a lot of information up front as a summary, and I can click through. This is a demo VM that was actually deployed via CAM. And I can see a lot of information about that VM, that it's a 2 CPU, 3.5 gig machine running Ubuntu 16.04. We discover a lot of information about individual VMs and their relationships to other systems such as networks. We also have a capability to deep scan a system and look in at the users and groups or packages that are installed on that system. There's a rich tagging system available in infrastructure management where you can create your own tag hierarchies and then apply those tags to the various machines that are found. And this allows you to do a number, to group them differently for other parts of the system, such as reporting and some of the other capabilities. So briefly, I want to talk about exactly how infrastructure management works. So when you add providers, we actually spin up workers to go and real-time collect information from that management system. As the data is pulled in, we pull in inventory and relationships, metrics such as CPU utilization and memory utilization, and events. All this information is pulled in near real time, stored in a database, and on top of that database is a rich set of capabilities. One of those capabilities is reporting. Infrastructure management has a very powerful reporting capability where users can create reports. The reports, there's a number of out-of-the-box reports, and then a user can also create custom reports. Let me do this differently. I'm going to add a new report. You can base the report on any of the models that we have stored. So in my case, I'm going to create one for virtual machines, and all of the fields that we have collected for virtual machines can be reported on. There's a huge list of fields. For now, I'm just going to pick name and OS name. And then once you've built the basis of your report, you can actually do a number of other things, such as group roll-ups. You can do formatting, which shows it as human readable name or a truncated string. In the case of numbers, you can show it as full number or a unit number, such as 1 GB. You can also do styling. So you can change the color of what the presentation looks like based on certain conditions. This is typically used for things like CPU utilization, where you want to say over 70% utilization, I want to display as red to really catch the eye of the user, or under 10%, I show it as black, so it can't really be noticed. There's filtering, summary, there's charts, where if you have numeric data, you can present it as a chart. And these reports can be saved, they can be executed, they can be run on schedules, and they can also be emailed. So a very common use case is for reports, global reports about the state of your environment on a weekly or monthly basis, emailed to a CIO. Reports are the basis for the dashboard, which you saw earlier. Dashboards are, each one of these is a report. So a user can create their own reports and present them on the dashboard for whatever they need or for whatever they deem important for running their business. One special kind of report that we have is a chargeback report. Chargeback is a way of specifying different rates for usage in your environment. You can specify rates for, different rates for compute or storage, how much based on allocation or use. We support CPU, memory, as well as storage. Chargeback reports use the metrics that we collect over a 30-day average to present the cost of the usage in a summary. Here are some reports that I've run, and I'll take an example one. The reports can be run against VMs in group, and this is where the tagging comes in. You can tag your machines to group them a particular way and then run reports on those tags. So in this case, I've tagged a number of VMs from our VMware system and applied this rate. And as you can see, based on the usage, they cost $24 in this case of CPU and $24 of storage, plus some other fixed costs, which gives a total cost of $60. So that's it for chargeback. Next, I'm going to jump over to our policy engine. So infrastructure management is broken into 3 major parts. We have what's called insight, which is the inventory piece that I've shown you. The next part is control. Control is our policy engine. Policies are a collection of profiles, and those profiles are an event condition action grouping. What that means is when a particular event comes in, you can apply that. When that event comes in, you can look at a condition that you describe about the VMs that event applies to. And based on that condition, you can run an action. So for example, if a VM started event comes in, you can say that the condition is when that event comes in and a VM is tagged as production, then the action might be something like send an email to the IT administrator so that he's aware that a new VM was created. This is a very simplistic case, and you can make them more complicated or less complicated based on your needs. So we'll jump over to policies. I'm going to take a look at one example policy that I have here called Cmh Disk Policy. In this particular policy, when an event comes in, if the VM disk size is greater than 50 gigabytes, what we're going to do is mark this VM as non-compliant. This particular policy is what's known as a compliance policy. Compliance policies are ways that you can verify particular information about a VM and mark them as compliant or non-compliant. So if I go over to infrastructure providers and I take a look at my virtual machines, you can see right at the top here that there's a number of machines that have been marked as compliant. These were machines that I applied that policy to. So if I take a look at the first one, you can see that it was compliant. This was the effect of running this policy on this VM. Compliance policies can be run on a scheduled basis or as the VM comes into the system via events. In this case, the disk size was 600 gig, which is greater than the 50 gig of the appliance. So this is a compliant VM. And you can actually drill into the compliance. A compliance policy can have a number of policies applied to it. And you can look at specific policies to see which ones caused it to go out of compliance. So the third section that I would like to jump into after insight, which is the information about the machines, policy or control, which is the policy portion of our system, we have automate. If I go into automation, automate is a way to automate your systems after they've already been brought in. Automation is used for things such as provisioning, but it can also be used for day two operations, custom operations that the user wants to apply to their machines, a number of cases. Automate is a system for building this automation. And as you can see, it comes with a number of out-of-the-box automations for orchestration, operations, provisioning, retirement. There's a number of things available. Automation can be written in the embedded automation system directly. You can also call out to Ruby code that can be written by the end user. They can build their own automation. Here's an example, Ruby method. And all of this can be chained together in what we call state machines, which are workflows that can run various systems. For example, when you provision a new VM, you may want to put in steps to call out to third-party systems, to register with a CMDB, to email somebody. All of this can be built in Automate. In addition to Ruby code, you can also use Ansible playbooks. Ansible playbooks can come from an external Ansible tower, or we have a capability called embedded Ansible, where a user can specify their repositories of Ansible playbooks. So in this case, I've added a GitHub repository that contains 8 playbooks. And if I drill in on those, you can see the playbooks were pulled in. You add a remote repository, infrastructure management will monitor that repository and look for new playbooks that appear. And those playbooks can be used in automation or in the service catalog, which I'll get to in a moment. Ansible Tower job templates can also be brought in through an Ansible Tower provider. And those can also be used in automation or in the service catalog. So speaking of the service catalog, we'll jump there next. Service catalog is a day one catalog. IT administrators can use this to offer virtual machines, containers, Ansible playbook executions to their end users by creating a catalog with choices that the user can make. In this case, I have a catalog with 2 catalog items. Catalog items can be created. So if I go here and say add a new catalog item, you can see there's a number of choices from Amazon templates, Azure, OpenShift, VMware, VMware Content Library. So IT administrator would create a new service catalog item and place it in a catalog. And those catalogs can be presented to end user. There's also a capability to build dialogues. So when you provision a VM, there's so many choices that go into that. And IT administrators do not want to offer that many choices to their end users. They want to make it simpler, and they want to make sure they have control around their IT systems. So this allows them to build dialogues that can be as simple as something like a small, medium, large dropdown. And the end user doesn't have to know what's behind that. So let me jump over to the catalog real quick that I have already built, and I'll take a look at this RHEL 7 one. So what I've done here is I've created a catalog around a RHEL 7 VM, and the user can then order it. When they order it, as you can see, all they're given is a choice of small, medium, and large. And I can make this more detailed and say that this is a 2 CPU, 4 CPU, 8 CPU, for example. But a dialog can be fully customizable by the end user. Checkboxes, radio boxes, drop downs, text boxes for information, anything that the IT administrator can think of. This data in this form is then sent over to Automate, where they can write code to take that apart, to say that if a small is given, that means a T2 small on Amazon, for example. And they can do all kinds of logic that they need that makes sense for their business cases. So in this case, an end user can choose small, press submit. I'm not going to do it here in the demo because provisioning a VM can take some time, but that is what is offered in a service catalog. We can also wrap orchestration template systems such as Amazon Cloud Formations or Heat or Azure templates. We can connect out to CAM, and I want to present that as part of the provider section.
Okay.
Okay, so I'm going to just jump back to the dashboard and start from there. Okay, so another provider type we have is under the configuration section. We can connect to configuration providers. This includes Red Hat Satellite or Foreman, as well as CAM. So I have created a CAM connection here. And if we click through to that, we can see that CAM has 68 what we call configuration profiles. These are the Terraform templates provided by CAM. And as you can also see, there were 10 systems that were deployed by CAM that we found. So if I drill into those 10 systems, you can see that were provisioned by Terraform through CAM. And I'll click through this example demo 1 VM right here, where we found information about that. We can see that it was deployed on Microsoft Azure with 2 CPUs. But we also, knowing it came from CAM, but we had the Azure connection in our system at the same time, we can cross-link those two and show information that we obtained from Microsoft Azure directly about that VM that was created by CAM. So if we click through on this instance, we're taken over to the VM that I showed earlier, which was that same demo VM. And if I scroll through, we can actually see some of the label information that was created. And here's an example tag that was created through CAM where the environment is set to QA. The last thing I want to talk about is the deployment of infrastructure management. There's 2 deployment models. One is virtual appliances. We have virtual appliances for VMware vSphere, Red Hat Virtualization, OpenStack, and Amazon AWS. These appliances are run on x86 systems, and a single appliance can be deployed, but if more compute is needed, multiple appliances can be deployed in a multi-server architecture. And then the servers can be configured with different roles, so you can apply workloads to different machines, as well as you can even put them on different networks for network management of those systems. Additionally, we have a deployment model for containerized systems supporting OpenShift cloud platform. OpenShift can run on x86, Power, or Z systems, and the same application runs just in a containerized format. And I think that's it. Seville, is there anything else you wanted me to talk about?
No, I think that's perfect. Thank you, Jason.
Jason, thank you very much for the great demo. Thank you, Ian, for the great demo. I think we're going now to briefly go back to the presentation pieces, and Seville is going to talk through the use cases that we usually see. Over to you.
Thank you. So Ian, just to summarize and bring it back fresh to in everybody's mind. So Ian, what he demoed is the provisioning of the IT capability and how we're bringing the infrastructure as code into the mix here to make it easier and faster for the clients, and how we're managing the services. It really means that once the IT admin sets the environment up the way that Ian had described it, they're really creating this standardized and compliant environment for DevOps teams to use, right? And it has this built-in self-service catalog that then integrates with the enterprise-wide catalogs through the APIs and so on. Jason spoke to the managed IT and the life cycle component. He talked about the discovery and the inventory and the insights with the reporting and the controls that could be established with this toolkit. It really is put together and designed to support the hybrid cloud environments, which we know quite a few of our clients still are in this mode, a little bit on-prem, a little bit on the cloud. Some people are starting to utilize. So this is the sweet spot, and this is designed to support our clients as they go into adopting more of the cloud capabilities. And then finally, we'd like to share with you some flexible integrations, out of the box available integrations that would facilitate, again, the idea of deploying, provisioning, automating the infrastructure.
Okay. Thanks, Seville, for introing the integration. So what I'll do is talk about a few of the use cases for integrations between the infrastructure automation module and the rest of the AIOps portfolio, as well as beyond that. This first case is about the integration with Servicenow. Within the AIOps AI Manager, we have integration with Servicenow that allows us to score the change requests to identify which change requests are risky and what the risk value that is associated with them. From the infrastructure automation side, we also have integration with Servicenow such that when we do the provisioning of the infrastructure, we can call into Servicenow to create tickets that require approval, and they go through the approval process before being turned back to infrastructure automation to actually do the provisioning with Terraform and Ansible. And then we also call out to Servicenow to update the CMDB. So these two parts of AIOps can be used together such that when an infrastructure change is being made, AIOps, through its change risk module, can look at previous changes that are similar to that one and then make a recommendation about how risky it is. And based on the approval that is given by the Servicenow user, then infrastructure automation can close the loop and carry out that automation task if the risk is sufficiently low. So now you have kind of the end-to-end flow from provisioning requests to scoring the change risk requests to carrying out the actual provisioning operations and updating the CMDB. So that's one use case. Let's talk about the next use case. So this is about GitOps and the ability of infrastructure automation to be driven via APIs and integrate with things like Argo CD, such that all the operations that are required or desired to be made are recorded in Git, and then the changes are carried out with IA through its APIs. So this is similar to the Servicenow integration, but now we're using the GitOps model for handling all the infrastructure changes. So with this, you can get a secure and auditable flow, all the changes that you make, and it works together with the Servicenow integration that we talked about before, such that all the operations are managed through infrastructure as code. So your development and your DevOps processes and your CI/CD pipelines can be aware of the changes that are being made on the infrastructure side, and IA carries out those changes and updates the relevant tools to reflect the status. Okay, so that's the GitOps case. The third use case that I wanted to discuss with everyone is the integration between infrastructure automation and Turbonomic, right? So Turbonomic provides that recommendation engine that looks at all the resources that are allocated and decides whether they should be resized or additional replicas should be created or more instances should be created or whether VM should be moved from one cloud provider to another cloud provider. So Turbonomic is the brains that does and makes those recommendations. This integration between IA and Turbonomic allows the two systems or the two parts of the AIOps portfolio to work seamlessly together. So the integration is such that when a resource is provisioned through infrastructure automation and configured during day one types of scenarios, then we inform and update Turbonomic about that. Turbonomic will discover the VM, but we will actually set and create the services and policies in Turbonomic so that it monitors that VM, and then when it takes actions or when it decides an action is needed, it will call back into IA. So the end result of that is that you have one consistent action or provisioning engine for both day one initial state provisioning as well as day two changes that are made by Turbonomic or that are determined to be required by Turbonomic. So again, this is kind of linking all the parts of the AIOps portfolio. You can use IA independently of Turbonomic and Turbonomic independently of IA, but when you do use them together, then you get a seamless flow between them. And this is all integration that works kind of out of the box, right? So changes made in Turbonomic are carried out by IA, and the system is consistently maintained. So the last use case is really an integration primarily with tools, patch management tools like Ansible Tower, for example, such that IA can be part of that overall patch management solution use case. So we have three scenarios in here where we can interface and provide value around the patch management use case. One is the patching of the golden image that is used to create VMs. So just like any initial VM provisioning, you can use the Ansible and Terraform integration that we have in IA to take a VM from an image, apply patches to it, and then save that VM as a new image that represent the updated patched image that will be used to create VMs in the future. So that's one use case that is supported. The other use case is about patching of running VMs, right, without updating the image or without even destroying them. And this is accomplished through the day two operations workflows that exist and that were demonstrated by Ian in the infrastructure automation module, the CAM and Terraform module. Basically, it can trigger Ansible playbooks that apply the patches against VMs. The third use case for patch management is to use a policy-based approach that was demonstrated with the policy engine in the infrastructure management component of IA. So you can use the event action framework and the policy to scan your VMs for missing patches, and then if they exist, then apply the patches and update those VMs. And you can do this on a scheduled basis, on a periodic basis, or manually triggered and so on. So the policy engine in IAM provides that capability.
Thank you, everybody. That was really insightful. I really learned a lot today. Seville, do you want to say a few closing words before we close this video?
Yes, so thank you for the time. We are available as a team to respond to any questions, of course. So please reach out. Our information is available, and please watch the space, especially with the integrations, because there will be more out of the box that is designed to facilitate the work of the IT operations team. So thank you.